So, hello friends. Now we'll understand how to use Chauvet's criteria to reject the doubtful reading, which is far away from our trend of the data. Okay. So, what is the procedure for this? First, you need to calculate mean, and from the mean, calculate the standard deviation. From the standard deviation, we calculate the deviation, not standard deviation. Then you calculate the sample standard deviation. Okay. So three things we have to do. First, calculate mean, because mean is needed for calculating the deviation. Once deviation is there, you can find the sample standard deviation. Okay, that is sigma. Clear? Now we'll see the table by Chauvet's criteria. It tells when to reject the particular reading. Okay, so that is table. So I have given only the sample data. I will send you the complete table. Okay, so this table Chauvet's criteria is giving the number of readings taken. So that is the first column, and second column is d max by sigma. So permitted value of deviation divided by sigma. Okay. Suppose you have taken the 10 readings, permitted di by sigma, maximum permitted di by sigma is 1.96. And if you calculate di by sigma, and if that di by sigma is more than 1.96, then what we have to do is we have to reject the reading. I'm again repeating, what we have to do is we have to calculate di by sigma for each reading. Okay. Suppose your number of readings for particular case is 10. Okay. You calculate di by sigma for all the readings and then check whether any reading is having di by sigma more than 1.96. If it is more than 9.6 is there, means what? We have to reject that reading. Okay, we have to reject that particular reading. If it is more than what? 1.96. Okay, first column is number of readings. Okay, so we have taken the reading 50 readings, and we calculated all di by sigma. And if any reading is having more than 2.56 di by sigma, then that reading we have to reject. Okay. So this is the Chauvet's criteria, and he has given the table for this. I will send you the table. Okay, for rejecting the false reading. Okay, to rejecting the false reading. Okay. So
the false reading. Sorry to intervene. So false reading means it is error due to
error. It is an error. Maybe it's a human being or maybe instrument. Okay. So we have to reject that reading. Okay. So beside this Chauvet's criteria, some people think that if your readings are beyond 3 sigma, then you can reject that. But this is the Chauvet's criteria, and it links number of readings with the d max by sigma. D max means what? Beyond this, it is not allowed. D max. Okay, d max by sigma. Okay, so we'll just go and see the problem. Now we have already seen this problem. Now this is the reading. We have already earlier seen this problem, but that was for calculating standard deviation. Now in the same table, we have to use the readings. Now we have to reject the reading from this table using the Chauvet's criteria. So what are the number of readings here? Can anyone tell me what are number of readings in the table? 10. So we have to see in the Chauvet's criteria what is for 10. What is d max by sigma value? Okay, just I will go back. What is that value? it is for number of readings equals to 10, it is 1.96. Okay, so D max by sigma is 1.96. So we got from the Chownet's table D max by sigma. D max by sigma is how much we got? 1.96.
1.96.
Okay, our DI by sigma should not be more than this. If it is more than that, then we have to reject that reading. Okay. So, okay, we go in the next slide. Okay. So I already written that. Now, I have calculated for that DI by sigma. Okay. I have calculated DI by sigma. Okay. So you can see here our maximum value permitted is what? 1.96. So you can see this reading number 5 giving the DI by sigma. Reading number 5, it is crossing. So we need to reject this. Okay. What we have to do is we have to reject this. Okay. We need to reject this. So we have to reject this. Now only there will be 10 readings. Okay. So there is no table for 10. So we will use the same D max by sigma as 1.96. Okay. There is no table for, there is curve for this. You can see the curve. From the curve also you can read the D max by sigma. Okay. So now what you have to do is we have to reject this, and again you need to calculate everything. Okay. Again you need to calculate the sigma. Okay. Now we'll go further. Now our n is 9 now. Now you calculate for deviation. We need to calculate first what? Mean. So you just take the summation of that number except 5 readings. So you get summation as 51.8. Please calculate. 51.8. And how many readings are there? There are 9 readings. Not 10 now. We have rejected 5th reading. You can see here. After 4.
Okay, sorry.
Okay. So mean is 5.7. So from each reading, each reading is subtract now. Okay. So we are getting the deviation. This is what? DI means what? Deviation. Given reading minus mean. So we get this. What is called as deviation. Okay. From the deviation, you find the deviation square. Now what we are trying to find now? We are trying to find the sigma. So sigma is what? Summation of square of the deviation divided by what? 1 by n minus 1. Why dividing 1 minus 1? Because our readings are less than 20. Okay. So you calculate now sigma value. Now you will find that now standard deviation value is very less. Lesser the value, it is better, it is more accurate. Please understand. Lesser the value of sigma means what? It is having more closer to the center line, middle line. Okay. Is more closer to that. Okay, so you get now new standard deviation, and it is much more lesser than earlier standard deviation. So because of this, we got more confidence in the data. Okay, so we got the more confidence in the data. So that's where we have to solve. Yes, yeah.
This sigma we got 0.4615. So it means that 46% chances are there that it will be accepted, is it?
No, sigma is an error. What is we saw the sigma? Sigma is the
error.
Yeah. How it is indicating? It is indicating the spread about the mean. Okay. More the sigma, more is the spread. less the sigma, less is spread. When less the spread is good, more spread means
Correct.
what? Not good. Like we saw the example of boys, the
Yeah.
spread was more. It is not good. For the girls' case, we saw that the spread was what? Less. Like this. So less spread is good. Okay. Less spread is good. So this way we have to solve the problem. I will send some problem for Chauvinet's criteria to you. You need to solve. Also, I will send some problem related to this finding the area and percentage of probability. Okay. So both problem I will give. Okay. Is there any doubt here? In Chauvinet's
No.
criteria, what we are doing, we are first calculating everything. Okay. So what we need for calculating, we need first calculate the mean. Okay. From the mean, you will get what? Di. Then you find di square, sum of the di square, and then you divide by either n minus 1 or n. Then you find the sigma. Once you got that, you find the one table column called as di by, you find di by sigma. And you compare whether the di max by sigma value, whether any value is going up. If any value is going up means what? You have to reject. Then again you find for with rejected reading, you find x mean, you find di, summation of di square, you find the standard deviation. And it is obvious that in the new case, after rejecting, your sigma will come down, which is better. Okay, it is better. Okay. Again,
Actually,
in that case, in that case, you can again see whether any reading is going up of the di max by sigma. You again reject and again you proceed. Okay. 1 or 2 times you can do this. Okay. Is any doubt in Chauvinet's criteria problem? So today I will send the problem for both, finding the probability from the Z score and then Chauvinet's criteria. Okay. So if any doubt, you can ask. So
So you
Chauvinet's,
are going to share the slides, PPT?
yeah, I may or may not share the PPT, but I will share the material. Okay, I will send the Chauvinet's criteria,
Okay, sir.
this table. Okay.
Excuse, sir.
Okay.
Yes.
Is it possible to once again revisit what you call it as confidence interval?
Yeah. Okay. Okay. I will just revisit this.
Yeah, just 1 minute. Yes.
Yeah.
Thank you.
Please understand, whatever table I shared was like this. Okay. It is calculating the area from this left. Okay. Suppose I am here, Z is equal to something plus. Okay. So this is the area. But sometime our interest is about this middle line. About the middle line, if it is plus minus Z, plus minus 1, then what is this area? Okay, so for that we need the same table, but first we calculate for particular Z, and then we calculate for particular Z, and then we take the difference. What we do, we take the difference, and what we get a confidence level. Okay, what is confidence? What is the probability that reading will lie in that shaded area? For plus minus 1, it is 68.26%. If the Z is plus minus 2, it is 94.26% like this. Okay. Because table is from left to the right area.
Right.
But when we want about the middle line, what is the probability if it is plus minus 1? Z is plus minus 1. Okay. So that is the confidence level. And what are the chances of error? We call as level of significance. We already see level of significance. Okay. We already seen the sigma there. Okay. Level of significance earlier. Okay. Thank you.
Yeah.
Okay.
Thank you.
Yeah. So I'll stop here.
Yeah.
So, Excuse me, sir.
Yes.
So, you were supposed to send assignments, so that would be based on
Yeah,
this.
yeah. Based on this, I will go on sending, but I will send for this. Okay. For current topic, I will send. You just attach to the other topics. Okay.
Yes.
For current topic, I will send today. Okay. Thank you.